Hi, good day. Welcome in today's episode of DepEd TV. I am your teacher Jay, your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Are your learning activity sheets ready? What about your pen and paper? Great! Let's begin a fun and exciting lesson. For this lesson, you are expected to, first, write a formula for the nth term of an arithmetic sequence, and second, use the formula to find the nth term or the unknown term of an arithmetic sequence. Let's take it one by one. In the previous episode, we defined a arithmetic sequence and gave the next term by adding a constant number called the common difference, denoted by the letter D. For example, find the next three terms of the arithmetic sequence 3, 8, 13, 18, and so on. The terms are a sub 1, which is the first term, is equal to 3. A sub 2, or the second term, is equal to 8. A sub 3, or the third term, is equal to 13. And the fourth term, or a sub 4, is equal to 18. So, we will be finding a sub 5, a sub 6, and a sub 7. The common difference D in the sequence is 5. To get the next three terms, add 5 to each of the preceding term. What do you think the next three terms are? Give it a try. I'll give you 15 seconds. Thus, a sub 5 is equal to the sum of the fourth term plus the common difference. That's a sub 4 plus 5 is equal to 18 plus 5 is equal to 23. A sub 6 will be equal to 23 plus 5, that is equal to 28. And a sub 7 will be equal to 28 plus 5, and that is equal to 33. Great job! What about if the problem is to find the 100th term or the 250th term? Can you find the terms? Using the process that is illustrated a while ago will take much of your time and effort. There is a shortcut in doing this, and we will learn more about in this episode. Let's go to the next part. Before we find the other higher terms of a sequence, let us find first the lower terms. In the arithmetic sequence 3, 8, 13, 18, and so on, what is the 15th term? Give it a try. I'll give you 20 seconds. Ready? Go! Let's try to check your answer. By adding the common difference to each of the preceding term, we get the following values. Thus, the 15th term is 73. However, using this procedure to get any higher nth term would be tedious. Thus, a formula is necessary to find any nth term. Let us investigate on how to determine the nth term of a sequence. These terms can be written in the following manner as a shortcut. Our a sub 1 is equal to 3. Our a sub 2 will be equal to 3 plus 5 times 1, that is 8. Our a sub 3 will be equal to 3 plus 5 times 2, that is equal to 13. Our a sub 4 will be equal to 3 plus 5 times 3, that is equal to 18. Moving forward, we will have a sub 13 is equal to 3 plus 5 times 12, that is equal to 63. Our a sub 14 will be equal to 3 plus 5 times 13 is equal to 68. And our a sub 15 is equal to 3 plus 5 times 14, that is equal to 73. Thus, if we find for the 16th term of the arithmetic sequence, then a sub 16 is equal to 3 plus 5 times 15, that is equal to 78. We can conclude that using the pattern observed, the nth term of the sequence is a sub n is equal to a sub 1 plus d times n minus 1, where a sub n is the term that corresponds to the nth position, a sub 1 is the first term, and d is the common difference. Remember, the nth term of an arithmetic sequence with first term, a sub 1, and common difference d is given by a sub n is equal to a sub 1 plus d times n minus 1. Again, the nth term of an arithmetic sequence with a first term, a sub 1, and common difference d is given by a sub n is equal to a sub 1 plus d times n minus 1. Using the given formula will help you in determining the unknown in an arithmetic sequence without the worry of getting through a long and tedious process. Want some more? Let's go to the next part then. Let us apply this formula in solving the following. Find the 21st term of the arithmetic sequence 6, 9, 12, 15, and so on. Want to give it a try? Great! You have 15 seconds and it starts now. From the sequence, we can see that our a sub 1, or the first term, is equal to 6. Our difference is equal to 3. And our n is equal to 21. Using the formula, a sub n is equal to a sub 1 plus d times n minus 1, we will substitute these values. For a sub n, we have a sub 21 is equal to the first term, which is 6, plus the difference, which is 3, times n, which is 21, minus 1. A sub 21 is equal to 6 plus 3. 21 minus 1 is equal to 20. A sub 21 is equal to 6 plus multiply 3 and 20, you will get 60. A sub 21 is equal to, get the sum of 6 and 60, you'll get 66. Thus, the 21st term of this sequence is equal to 66. From the given sequence, we can notice that the third term, or a sub 3, is equal to 8, and the 16th term, or a sub 16, is equal to 47. First, we will use the value of a sub 3 is equal to 8 and substitute to find the nth term of the sequence. So that will be a sub 3 is equal to a sub 1 plus the difference times n minus 1. Next, using the value of a sub 3, we will use 8 is equal to copy a sub 1 plus d. For n, we will use 3, so that's 3 minus 1. Next, you have 8 is equal to a sub 1 plus d times 3 minus 1, that's 2. Then, you have 8 is equal to a sub 1 plus 2 times d, that's 2d. This will be our equation 1. Now, let's use the value for a sub 16. That's a sub 16 is equal to a sub 1 plus d times n minus 1. Next, substitute the value for a sub 16, that is 47 is equal to a sub 1 plus d. Our n, we will use 16 minus 1. Next, you have 47 is equal to a sub 1 plus the difference, and 16 minus 1 is equal to 15. Next, you have 47 is equal to a sub 1 plus d times 15 will give us 15d. So this will be our equation 2. Using equation 1 and equation 2, solve for the first term, a sub 1, and the common difference, d, by subtracting equation 2 by equation 1. We will have the second equation, 47, is equal to a sub 1 plus 15d minus equation 1, which is 8, is equal to a sub 1 plus 2d. Remember that when you get the difference of these two terms, you're going to change the sign of this subtrahend to its opposite. So your 2 positive will become negative 2. This will be also negative, and your 8 will also become negative, and you will proceed to addition rules. Next, simplify. We have 15 plus negative 2 will give us 13d. A sub 1 plus negative a sub 1 will give us 0, so this will be cancelled. And 47 plus negative 8 will give us positive 39. Next, isolate d by dividing both sides by 13. So that's 13, and divide by 13. 13 divided by 13, what's left will be d, and 39 divided by 13 will be 3. Therefore, the difference of the two equations is equal to 3. Now, to solve for a sub 1, substitute d is equal to 3 to either equation 1 or equation 2. For this example, we will use the first equation. That is, 8 is equal to a sub 1 plus 2d. Next, we have 8 is equal to a sub 1 plus 2 times the difference, which is 3. Next, we have 8 is equal to a sub 1 plus 2 times 3, that is equal to 6. Next, we'll have 8 transpose 6 on the left side of the equation. That will become negative. So that's 8 minus 6 is equal to a sub 1. And 8 minus 6 is equal to 2. Therefore, our first term, or a sub 1, is equal to 2. Thus, the nth term of the arithmetic sequence is a sub n is equal to 2 plus the difference 3 times n minus 1. Using this equation, a sub n is equal to 2 plus 3 times n minus 1, we can solve for the value of the 71st term. Using a sub n is equal to 2 plus 3 times n minus 1, we can solve for the 71st term. We will use, again, a sub n is equal to 2 plus 3 times n minus 1. Again, we are looking for the 71st term, so we will substitute 71 for our n. So that's a sub 71 is equal to 2 plus 3 times 71 minus 1. Next, we have a sub 71 is equal to 2 plus 3 times 71 minus 1 is 70. Next, we have a sub 71 is equal to 2 plus the product of 3 and 70, that's 210. Add the two values, that's 2 plus 210, that's 212. Therefore, our 71st term is 212. Let's keep on practicing. There's more. Here's another way in solving the difference d. There is an alternative solution, or another way to solve d, or the difference, using the formula d is equal to a sub n minus a sub k all over n minus k. Just take note of the following details. Our given a sub 3 is equal to 8, and our a sub 16 is equal to 47. From the formula, we can have a sub n is equal to a sub 16. We will use the value, which is 47, and for n, we will use 16. For a sub k, that is equal to a sub 3, which is equal to 8. And then we will use the value of a sub k. So k will now be equal to 3. Then we will substitute this given to the formula to find the common difference. So that's a sub n minus a sub k all over n minus k. So that is 47 minus our a sub k, which is 8, all over our n, which is 16, minus our k, which is 3. Subtract these values, we can get 47 minus 8, that is 39. And 16 minus 3 is equal to 13. Then, divide 39 by 13, we will have 3. So the difference is still 3. Good job! Did you answer all the problems correctly? If not, don't worry. Just take note of those items and keep on practicing. It's think time! Let's see how you understood today's episode by answering the questions that follow. Ready? Item number 1. State the general formula of finding the nth term of an arithmetic sequence. Item number 2. Given an arithmetic sequence, how do we find the common difference? Item number 3. Given two different nth terms of an arithmetic sequence, how do we find for the common difference? I hope that with your answers, you have fully developed your understanding regarding this topic. So awesome! Now, it's time to apply what you have learned in the entire content of this episode. Give what is asked. Item number 1. The 10th term of the arithmetic sequence if a sub 1 is equal to negative 15 and d is equal to 6. The correct answer is 39. Item number 2. The 39th term of the arithmetic sequence if a sub 1 is equal to 40 and d is equal to 1/2. The correct answer is 59. Congratulations for a job well done. I hope you learned a lot in today's lesson. And that concludes our lesson for today. For the next episode, you are going to learn how to compute arithmetic means. And again, this is your teacher Jason also. Bear in mind that learning math is and will always be easy. Be also, be awesome. Only here on DepEd TV.